The reason why we don't want to use the term perpendicular, because it is not in the sense of a 90 degrees using two straight lines. So for example, given the curve f, any curve that intersect this curve orthogonally or form a 90 degrees angle is called the orthogonal trajectory. For example, find the orthogonal trajectories of the family of curve x times y equals a, where a is not 0 and arbitrary constant. We first start with y equals a over x, so we isolate y. And since we are looking for the orthogonal trajectories, we have to find the derivative, which is the slope of the tangent line. The derivative is negative a over x squared, which we can separate this and write it as negative a over x times 1 over x, which is negative y times 1 over x, or negative y over x. We know that this is the differential equation, dy dx equals negative y over x. Any orthogonal trajectories to the curve must have a slope of dy over dx equals x over y. And that is, since the original curves have the slope negative y over x, the orthogonal trajectory have to have the negative reciprocal, which is x over y. And we see that this is the separable differential equation, y dy equals x dx. We integrate both sides of the equation with the corresponding variable, y on the left and x on the right. We have y squared equals x squared plus 2c. And we recognize that this is a family of hyperbolas. For example, if a equals 1, then we might have y equals 1 over x. And so a family of orthogonal trajectories perhaps would be something that looks like this. Orthogonal at the point of intersection. The trick to find the orthogonal trajectories of the family is that when we differentiate y to obtain dy dx, we want to relate the derivative in terms of the original function y. So for example, when y equals a over x, we have dy dx, which is negative a over x squared. But we don't want to take the reciprocal of this. We want to rewrite this negative a over x squared in terms of y and x to obtain a differential equation.